For this problem, we're going to take a look at this complicated limit. The limit as x goes to negative infinity of x squared minus 5x plus 4 sine x over 2x squared plus x cosine of x cubed minus 10x. To get started, I'm just going to first simply recopy the limit that I'm supposed to do, and then we'll start talking about what we're supposed to do with this. So that's the numerator, and then let me copy the denominator. And now the general technique is always going to be to multiply top and bottom by 1 over the highest power of x in the denominator. Now, in this case, you might be tempted into thinking that the highest power of x in the denominator is x cubed. However, the x cubed here is within the cosine function. So I don't see this x cubed as by itself. That's within the cosine function. So I'm not going to divide by x cubed. The highest power of x in the denominator is x squared. And so I will multiply by 1 over x squared in the top and in the bottom. So let me rewrite that. Limit as x goes to negative infinity. Okay, so first let me just copy down what I had originally. So x squared minus 5x plus 4 sine x, all divided by 2x squared plus x times the cosine of x cubed minus 10. So far, all I've done is add a little extra space. I haven't done anything yet. And what I will do now is multiply top and bottom by 1 over x squared. So I've done the same thing to the top and the bottom, and so there's no change in the fraction. Okay, now let me multiply out in both the top and the bottom. The limit as x goes to negative infinity of x squared over x squared is 1. 5x over x squared is 5 over x. And then 4 sine x over x squared is just that, 4 sine x over x squared. In the bottom, 2x squared over x squared is 2. X over x squared is 1 over x, so I'd have cosine of x cubed over x, and then minus 10 over x squared. Okay, now ordinarily in algebra class, you get points taken off or something like this, where I make the expression even more complicated than what I started with. However, I do this on purpose because all these fractions here are going to have a limit of 0. And so let me do the scratch work on the side. If I take the limit, and you don't have to write the scratch work like this on these for exam purposes, but for the review, I'll write this out so that you see what we're doing. The limit of 5 over x or anything over x as x goes to negative infinity, that's 0. And for the one here, the simple one, the limit as x goes to negative infinity of 10 over x squared, that's also equal to 0 because x is going to negative infinity. Same would be true if it was plus infinity. Okay, now the other two fractions require a little bit more thought, and we've done this in class, so you don't have to do this on the exam, but for review purposes, let's remind ourselves as to why this works. For this fraction right here, I know that 4 sine x over x squared, that's guaranteed to be less than or equal to 4 over x squared, and that's also less than or equal to negative 4 over x squared. Okay, and so sine of anything takes values between negative 1 and 1. And so if I multiply by 1, multiply by negative 1, I know that 4 sine of x is going to be between negative 4 and 4. And therefore, 4 sine of x over x squared will be between 4 over x squared and negative 4 over x squared. And since both the limit as x goes to negative infinity of 4 over x squared is equal to 0, and the limit as x approaches negative infinity of negative 4 over x squared, that also equals 0, we know that the limit as x approaches negative infinity of 4 sine x over x squared is equal to 0 by the sandwich theorem. This bigger thing goes to the 0. This smaller thing goes to 0. This is in between. And so the thing in between has nowhere else to go except for 0 as x goes to negative infinity. Okay, now the last one is going to be roughly the same logic. Okay, so I've got on screen here cosine cubed over x. Okay, so we also know that cosine cubed over x, that is going to be somewhere between 1 over x and negative 1 over x. The cosine of anything must be between negative 1 and 1. And even something as complicated as x cubed, the cosine of anything, including x cubed, must be between negative 1 and 1. And again, since the limit as x approaches negative infinity of 1 over x is equal to 0, and the limit as x approaches negative infinity of negative 1 over x equals 0, we know that the limit as x approaches negative infinity of cosine of x cubed over x equals 0 by the sandwich theorem. Okay, so coming back to the original derivation here, all of these limits here are very straightforward to evaluate. I have 1 minus 0 plus 0 all over 2 plus 0 minus 0. Okay, all of these limits turn out to be 0, and so I end up that the limit is simply equal to 1/2. And so this very complicated expression here, almost everything doesn't count except for the coefficients on the leading terms, and so I get a limit is equal to 1/2. This can be checked on your calculator. If you graph this function on your calculator and look at large negative values of x, you can see that the y coordinates will get closer and closer to 0.5. And so that is a graphical check of this work that can be done on the exam.